Hello students, we are going to start a very important and very interesting part of physics, and that is optics. Optics is a very independent branch with respect to what you have learnt in physics, and it is very interesting, very mathematical, and has a very big physical representation and interpretation. अगर शुरुआत से ही Hello students, we are going to start a very important and very interesting part of physics, and that is optics. Optics is a very independent branch with respect to what you have learnt in physics, and it is very interesting, very mathematical, and has a very big physical representation and interpretation. अगर शुरुआत से ही concepts को आप properly catch करेंगे, I am sure you will develop a very big interest in the topic, और ये topic एक अच्छा मार्क स्कोरर एरिया बन जाएगा आपके एग्जामिनेशन के लिए. बट इन ऑर्डर टू एक्सेल ऑप्टिक्स देयर इज ओनली वन सिंपल प्रिंसिपल, और वो ये है, जितने भी प्रॉपर्टीज और जितने भी इंपॉर्टेंट प्रॉपर्टीज हम डेवलप करते हैं, उन प्रॉपर्टीज को आप अच्छी तरह से मेमोराइज करेंगे, एंड यू विल सी द एप्लीकेशन पार्ट बिकम्स वेरी इंटरेस्टिंग. सो लेट्स बिगिन विथ ऑप्टिक्स. One of the oldest branch of physics. ये शायद आपके लिए unimaginable होगा कि optics is as old as mechanics. And the credit of development of optics again goes to the same great man, Sir Isaac Newton. Newton ने optics branch पे particularly काफी ज्यादा और काफी important contribution दिए है. जैसे कि उन्होंने mechanics में contribute किए है, ठीक उसी तरह से he has made high degree of contribution in optics. So the branch goes somewhat 400 or 450 years old. But as time passed, optics is such a branch which saw many evolution. यानी समय के साथ साथ optics में बहुत ज़्यादा changes आ गए और बहुत ज़्यादा modification आ गए, और आज के डेट में present age में जो optics हमारे पास है, it's a very wide brand and a wide branch of physics. There are many types of optics, but if we broadly categorize, we'll see two different types. And that is, number one is the wave optics, and number two is the ray optics. First of all, definition पे concentrate करते हैं. Definition के मुताबिक here light behaves as wave in nature, and here light behaves as ray in nature. आपके general thought और आपके general intuition को first point challenge कर सकता है if you haven't heard it before. Light is wave in nature. That is what point number one says. जबकि day to day experience या day to day events जिसको भी आप देखते हैं, जिसको भी आप observe करते हैं, you always observe light in the form of ray. But it is again astonishing and it is again surprising that light has wave characteristics in it. Let me start with the formal definition. और definition ये है, light is an electromagnetic wave. Again I said, it may surprise you. Such a thing, light, which we assume to travel in a straight line, starts with the definition, light is an electromagnetic wave. And if we talk of the wavelength of visible light that comes from 400 nanometer to 700 nanometer. Although critical definition of the wavelengths is very difficult, but ये एक average value है जिसको हम सभी accept करते हैं. और 400 नैनोमीटर ये वेवलेंथ है फॉर ब्लू कलर, और 700 नैनोमीटर ये वेवलेंथ है फॉर रेड कलर. दिस इज अ वेरी ब्रॉड एंड अ वेरी ब्लंट डेफिनेशन ऑफ लाइट. देन अगेन द क्वेश्चन इज स्टिल अनसॉल्व्ड. हाउ डज लाइट बिहेव एज रे इन नेचर? वन स्मॉल फैक्ट, लेट मी राइट इट, और जिसके प्रूफ विल डू व्हेन वी लर्न द वेव ऑप्टिक्स पार्ट. In the present lecture, we will be concentrating on ray optics. तो मैं आपको condition दिखा दूं, validity दिखा दूं कि जिस अवस्था में light will behave as ray in nature. The question comes, if wavelength of light is very much smaller than the size of obstacle. जैसे कि day to day life में if an opaque object is kept in front of a light source, हमें पता है a shadow will be formed behind on the screen. That means the obstacle, which may be a disc, which may be a square, that is the size of the obstacle. And the wavelength of light is given here. Means if the wavelength of light is very, very less than the size of obstacle, then light travels in a straight line. In fact, why do we take light as ray in nature? What I mean to say is, if somebody says light, then based on the knowledge that we have till date, moment somebody says light, तो एक visualization जो दिमाग में आती है, straight line. I'm just trying to give an explanation why that visualization come to us, because this is the world where we live in. This is the world which has an experience in us. Imagine anything that you encounter in day-to-day life, चाहे एक छोटी सी ऑब्जेक्ट हो या एक बड़ा सा ऑब्जेक्ट हो. In our day-to-day life, you have an object of size you may say, or area you may say 1 centimeter square, या 10 meters square, and so on. But whatever are the objects that we meet in day-to-day life, those size comes at around meter. And that meter is very, very much greater than the wavelength of light, which comes in nanometer. Yani, this is the world where we are living. In other words, हम जिस दुनिया में रहते या हमारे जो डे टू डे एक्सपीरियंस है वो इस कंडीशन को सेटिस्फाई करता है. And under this condition, light will travel in a straight line. And that opens up the branch of optics, what we call as ray optics. That is what we are going to study. यानी हम पढ़ेंगे इमेज फॉर्मेशन, हम पढ़ेंगे शैडो फॉर्मेशन. एक टिपिकल एग्जांपल लेते, एक प्लेन मिरर रखा गया है in front of a light source. You could see the size of the plane mirror. That's in the order of meter. और वो size of plane mirror या वो size of obstacle is satisfying this condition. So there we readily and we happily take light as ray in nature. So I hope you got now one domain. I would not like to touch this domain because that's a detailed study in the coming lectures. But today we'll start with this particular domain where light would travel in a straight line. और उस property को हम कहते हैं rectilinear propagation of light. That's a situation when light travels on a straight line. Or under this condition, under this domain, हम light को एक straight line के form में represent कर सकते. That is the situation, and this thing we denote it as ray. It's a finest mathematical approximation, and a very thin beam that can be called as a ray, but that is valid under the assumption of rectilinear propagation of light. और अगर ऐसे collection आ जाता है, if it is a bundle of rays, then those bundle of rays would be called as the beam. So when we are in the domain of rectilinear propagation of light, हम light rays को या light waves को in the form of ray represent करते, and this is the representation that we take. So based on this, now we'll start the laws of reflection. A very common laws जिसको आपने जूनियर क्लासेस में भी पढ़े होंगे, but this time the law is same, but आप देखोगे the application parts are infinite in number. First of all, the laws of reflection is defined for a point. So you should not have a confusion कि laws of reflection सिर्फ एक प्लेन मिरर के लिए वैलिड है. किसी भी प्रकार का मिरर हो, चाहे वो प्लेन, कर्व्ड और कर्व्ड में कोई भी शेप, the laws of reflection would be valid, because I have said the laws of reflection is defined for a point on the mirror. और अगर एक पॉइंट के बात करेंगे, चाहे वो प्लेन मिरर हो, चाहे वो एक कर्व मिरर हो, एक पॉइंट के लिए the environment and the situation would be same. So what is laws of reflection? First of all, number one is angle of incidence is equal to angle of reflection. और जो कि आपको पता है, angle of incidence है angle between incident ray and normal at that point. अगर मैं एक प्लेन मिरर के हेल्प से दिखाऊं, ये एक प्लेन मिरर है and this is the light ray which is coming, तो इस पॉइंट पे हम एक नॉर्मल बनाएंगे और इस चीज को कहते हैं एंगल ऑफ इंसिडेंस. Light will be reflected following that rule. This is angle of reflection and that is equal to angle of incidence. And similarly, plane mirror के बदले में अगर कोई curve mirror हो, and imagine light is falling in this way. This is the incident ray. The first job, इस point पे एक normal बनाएंगे और ये है angle of incidence. फिर the same property, angle of incidence equals to angle of reflection. So that's the first law of reflection. और second law की बात करते हैं. Second law ये कहता है incident ray, reflected ray and normal are कोप्लेनर. आप देख सकते हैं, चाहे ये फिगर के एग्जाम्पल लिया जाए या ये फिगर, इंसिडेंट रे, रिफ्लेक्टेड रे और नॉर्मल, ये तीनों ही चीज एक ही प्लेन में, द प्लेन ऑफ द बोर्ड. एंड सेम इज द सिचुएशन हियर. द इंसिडेंट रे, रिफ्लेक्टेड रे एंड नॉर्मल all are in the same plane that we call as the plane of board. So this means validity of second law, coplanarity of all the situation, the example could be seen here. So these are the fundamentals. Now you will see, based on this fundamental, we can generate infinite number of concepts. देखते slowly and steadily. कंसेप्ट को आगे बढ़ाते बाय डिफाइनिंग अ टर्म इमेज. बाय दिस टाइम दिस शुड नॉट बी अ न्यू टर्म फॉर यू. और एक इमेज का फिजिकल अंडरस्टैंडिंग या एक इंट्यूटिव रीजनिंग दैट कैन इजीली बी फॉर्म्ड इन योर माइंड. सो यू नो व्हाट एन इमेज इज. But कोशिश करते to define image in the language of physics. So this image is the intersection of reflected ray. बाद में जब हम रिफ्रैक्शन पढ़ेंगे तो इसी सिचुएशन में दैट कम्स एज इंटरसेक्शन ऑफ रिफ्रैक्टेड रे. बट राइट नाउ लेट्स कंसीडर ओनली फॉर द रिफ्लेक्टेड कंडीशन. तो ये है डेफिनेशन ऑफ इमेज. यानी जो भी पॉइंट पे या जिस भी पॉइंट पे अगर रिफ्लेक्टेड रेज इंटरसेक्ट हो रहे, दैट पॉइंट विल बी द कोऑर्डिनेट या लोकेशन ऑफ इमेज। अब सवाल यह आता है, हाउ मेनी नंबर ऑफ रेज? एंड दैट पार्ट इज वेरी इजी इन ऑप्टिक्स। मान लेते मेरे पास एक रिफ्लेक्टेड रे ये है और दूसरा रिफ्लेक्टेड रे ये है। आप क्लियरली देख सकते हो, दिस इज द पॉइंट वेयर द टू रिफ्लेक्टेड रेज आर मीटिंग। सो ऑन द बेसिस ऑफ दिस हम कह सकते ये लोकेशन ऑफ इमेज है। बट somebody may ask a question, बाकी रेज को अगर ट्रेस करेंगे, क्या वो रेज भी इसी पॉइंट पे मीट होंगे? एंड दिस टाइम लकीली यस। कहने का मतलब न्यूमेरिकल में अगर आपने दो रेज का इंटरसेक्टिंग पॉइंट निकाला है, तो इट इज नॉट रिक्वायर्ड टू ट्रेस द अदर रेज, और अगर आप करेंगे भी, you will find this sort of result. So at this part, you could very easily see, at a point where two rays would be intersecting, the other rays would also be intersecting. Yani, it is more than enough to see the intersection of only two rays. Reason, जहां दो रेज मीट होंगे, बाकी रेज भी उन्हीं पॉइंट पे मीट होंगे। तो ये एक नॉर्मल टैक्टिस लेके हम चलते ऑप्टिक्स में कि जब भी इमेज ट्रेसिंग या इमेज फॉर्मेशन देखना है, वी टेक ओनली टू रेज बैंकिंग ऑन दिस फैक्ट। बट देन कम्स द टू टाइप्स ऑफ इमेज। वन इज द रियल इमेज, अनदर इज द वर्चुअल इमेज। Let me first show you the situation और define करते what is real image and what is virtual image। मैं आपको दो सिचुएशन दिखाना चाहूं। एक, इस प्लेन मिरर में मान लेते ये एक रिफ्लेक्टेड रे है और मान लेते ये एक रिफ्लेक्टेड रे है। डायरेक्शन ऑफ द एरो से आप इजीली बता सकते दिस इज द रिफ्लेक्टेड रे because the ray is coming back. और दूसरा सिचुएशन में this is one reflected ray and this is another reflected ray. Let's compare these two figures. इस सिचुएशन में it is properly visible. This is the point where the reflected rays are meeting. But the reflected rays are truly meeting. तो इमेज तो है ही, and more precisely that would be called as the real image. यानी ये जो लोकेशन है, that is the location of real image. इस सिचुएशन में देखते हैं। If you see in this situation, reflected ray को जितना मर्जी आप एक्सटेंड कीजिए, there is no chance of intersection of the reflected ray. Yani, there is no image at this point. But you would see that if you backtrace it, the ray appears to meet at this point. Yeah, the ray pretends to come from this point. तो इसको भी हम in the language of physics image कहते हैं, पर यह है virtual image. वर्चुअल इसलिए कि the reflected rays are not truly meeting. Therefore, this is called as a real image and therefore this is called as a virtual image. तो इस तरह से दो टाइप के इमेजेस हम क्लासिफाई करते हैं। One way of classifying is very easy. If the reflected ray truly meets and if the reflected ray do not meet, और हम उसको extrapolate करें back and it appears to meet here. Yeah, another way you could see, if after reflection the rays converge, तो ये जो सिचुएशन है, that's a condition to form a real image. और ठीक उसके अपोजिट, इफ आफ्टर रिफ्लेक्शन द रेज डाइवर्ज, जैसे कि यहां हम देख सकते हैं दिस इज वन रे, दिस इज अदर रे एंड द रेज आर डाइवर्जिंग, तो ये जो सिचुएशन है दैट विल फॉर्म अ वर्चुअल इमेज. So this is for the real image and this is for the virtual image. अब बात करते object. At least in your junior classes you had learned this thing, what is real image and what is virtual image. But यही concept it's also extended for object. कहने का मतलब even objects may be real and virtual. So let's see the situation of real and virtual object. First of all, let's try to define object in the language of physics. That will simplify our job. और जो object का definition हम देते वो है intersection of incident ray. So it's very easy. Image के केस में ये है intersection of reflected ray if it is the image due to reflection. और object के केस में it is the intersection of incident ray. मान लेते एक plane mirror के सामने I place an object. It could be anything. एक object like let's say this chalk, it is kept in front of a plane mirror. All of us know from an object many incident ray will start emanating. So these are the incident ray out of which I'll make only two. और आप यहां देख सकते हैं ये जो पॉइंट है ये दो इंसिडेंट रे के इंटरसेक्टिंग पॉइंट है और ये दो इंसिडेंट रे इस पॉइंट पे ट्रूली मीट कर रहे, इसलिए ये जो पॉइंट है दैट इज द केस ऑफ रियल ऑब्जेक्ट. But let me show you an example where even virtual object can be formed. In fact, ये जो situation है, you will get when we deal with multiple stages of reflection and refraction. जैसे एक lens, mirror, lens या कोई भी एक arrangement रखा गया हो. But let me prepare you beforehand for this situation. मान लेते this is the mirror. And let's say the ray is coming in this way. Don't at all get interested ये rays कहां से आ रहे हैं. अगर आप ध्यान से डायरेक्शन को देखेंगे तो this must be the incident ray क्योंकि it's incident on the mirror. अब देखते where is the incident ray coming from. If I backtrace it क्योंकि ये diverging ray है तो आप देख सकते हो देयर इज नो चांस ऑफ मीटिंग. तो अगर इसको हम एक्स्ट्रापोलेट करेंगे तो आप देख सकते हो हियर इट अपीयर्स टू मीट एंड व्हाट अपीयर्स टू मीट, ऑफ कोर्स द इंसिडेंट रे. सो दिस इज द इंसिडेंट रे विच इज नॉट मीटिंग बट अपीयर टू मीट, देयरफॉर दिस वुड बी कॉल्ड एज द वर्चुअल ऑब्जेक्ट. So this is how virtual object is defined. यानी we were not interested where the ray is coming from, but हमें ये जरूर पता है ये दो रेज इस मिरर के लिए इंसिडेंट रेज है और there is no chance of meeting of the incident ray. Compulsively हमने इसको एक्स्ट्रापोलेट किया, so that's a case of virtual object. यानी if I try to define virtual object in a formal way, you could say in this way. If a converging set of incident beam, आप देख सकते हो a converging set of incident beam is blocked by an optical element. I don't want to say mirror. हो सकता है वो एक लेंस हो सकता है वो एक कर्व्ड रिफ्रैक्टिंग सरफेस हो, कुछ भी हो सकता है. Therefore, let me call it as an optical element. then virtual object is formed. जैसे ये सिचुएशन, converging set of incident beam तो है, but this is being blocked by an optical element. So this is a situation favorable for the formation of virtual object. यानी with this discussion ऑब्जेक्ट को आप एक लार्जर व्यू से देखने लग जाएंगे. आप ये नहीं है कोई चीज रखा है बस उसी को ही ऑब्जेक्ट कहेंगे. द लैंग्वेज ऑफ ऑप्टिक्स सेज ऑब्जेक्ट इज द इंटरसेक्शन ऑफ इंसिडेंट रे. मान लेते दिस इज द सिचुएशन एंड हियर इज द मिरर. अब आप केयरफुली देख सकते, इफ वी आर नॉट इंटरेस्टेड वेयर इज द रे कमिंग फ्रॉम, हमें यह पता है दिस इज द रे विच इज हिटिंग द मिरर, यानी दीज आर द इंसिडेंट रेज फॉर द मिरर. तो यह नहीं है कि इंसिडेंट रे विल कम फ्रॉम अ फिजिकल ऑब्जेक्ट. इट इज नॉट दैट. इवन दिस सिचुएशन कुड बी फॉर्म्ड हियर. टू मेक द मैटर मोर रियलिस्टिक, क्योंकि यू हैव ऑलरेडी लर्न व्हाट अ लेंस इज इन योर 10th लेवल, सो बैंकिंग ऑन दैट फैक्ट, यहां एक फिजिकल ऑब्जेक्ट, वाकई में एक रियल ऑब्जेक्ट को रखा गया है. सो आफ्टर रिफ्रैक्शन इट केम फ्रॉम हियर. Now what is this? This is the refracted ray for the lens, and this is the incident ray for the mirror. The mirror says these are my incident rays, और ये जो incident ray it's coming from this point. यानी clearly पता है this is the case of real object, but for the plane mirror. अगर प्लेन मिरर के लिए या प्लेन मिरर का पोजीशन यहां के बदले में इफ आई वुड कीप हियर, तो आप देख सकते इस बार प्लेन मिरर के लिए इंसिडेंट रे ये है, एंड देयर इज नो चांस ऑफ इंसिडेंट रे मीटिंग. एंड इफ आई एक्सट्रापोलेट इट, इट अपीयर्स टू मीट एट दिस पॉइंट. यानी अब ये जो पॉइंट है इट वुड बी द वर्चुअल ऑब्जेक्ट फॉर द प्लेन मिरर. So I think with these discussion, concept of real and virtual image as well as real and virtual object must have been clear.
एड्रेस एग्जाम निकल जाएगा भाई, मैं तो रहा हूँ पर निकलेगा कुछ नहीं. यार ये लोग इतना वाले पोस्ट करना ड्रॉप लेने से.
So now let's see the concept of image formation on plane mirror. तो अब हम देख रहे हैं image formation in plane mirror. Let's see. There is a plane mirror and here is an object which is kept. How to trace the image? The concept: carry any two incident rays, any two of your choice, और वो दो इंसिडेंट रे के मुताबिक दो रिफ्लेक्टेड रेज भी मिलेंगे, and that will give you the location of image. Let's say if I consider one ray as this, obviously it will be reflected according to the law angle of incidence equals to reflection. और दूसरा रे, any one I can take, let me take this. So this would also be reflected according to the laws of reflection. Now we are ready to trace the image. First search reflected ray. यहां एक reflected ray है, यहां एक reflected ray. These reflected rays are not meeting. तो compulsively मुझे इन rays को back trace करनी होगी, and if I back trace, it appears to meet here. So therefore, this is the case of virtual image. Or by using simple geometry, you could prove that this distance would be equals to this distance. Now I would like to show you, ये दो रे के बदले में, suppose you had taken another ray. Say for simplicity, the ray going straight forward. Then it would be reflected back. तो ये reflected ray है. अगर इस reflected ray को भी back trace करेंगे, it would meet at the same point. That is what I am saying. कि अगर हमें दो reflected rays के back tracing से एक point मिल जाता है, it is for sure, even if you consider a next ray and when you back trace it, the ray is going to meet at the same point. Now, one point of confusion may occur. मान लेते this is a plane mirror and say an object is kept here. And the question is whether image would be formed or not. जो कि ऑब्जेक्ट डायरेक्टली मिरर के ऊपर नहीं है. This may act as a confusion. Then let's see what is the condition for image formation. इमेज बनने के लिए कंडीशन क्या है? रे फ्रॉम द ऑब्जेक्ट शुड हिट द मिरर. बात इतनी सी है. अब आप देख सकते हो ऑब्जेक्ट मिरर के सामने नहीं है, बट देयर आर इनफाइनाइट नंबर ऑफ रेज इमैनेटिंग फ्रॉम द ऑब्जेक्ट and some of the ray is certainly hitting the mirror. और अगर इंसिडेंट रे मिरर को हिट कर रहे, there will be corresponding reflected ray, and corresponding to that reflected ray you'll have image. Let's see, if I consider one ray as this, it would go in this way, and if I consider another ray, obviously it would go in this way. This is the normal convention we set to avoid confusion. One is with a single arrow, one is with a single arrow corresponding reflected ray, other is a double arrow corresponding reflected. It's very easy to see ये दो reflected rays diverge होके जा रहे, so there is no chance of meeting of these reflected ray. And if I backtrace, the rays are going to meet here, and that would be the location of image, and that is the virtual image. Now if I make a neat figure, आप देख सकते हो मिरर यहां है, ऑब्जेक्ट यहां है, तो इमेज इस लाइन पे नहीं बन रहा है. That's one of a common misconception to say image would be formed in this line. In your imagination, you can extend the mirror. That means the image would exactly form here as if the mirror was extended. So don't say the image would be formed somewhere here. So we got a very nice thing that it is not necessary to form an image the object should be exactly above the mirror. Requirement ये है जो ऑब्जेक्ट से इंसिडेंट रेज आ रहे वो इंसिडेंट रे मिरर तक पहुंचना चाहिए. So that will give you the image. In other words, if I have this object, this is the head of the object, foot of the object, and this is a plane mirror. And a question may be there whether complete image would be formed or not. And the answer is a blunt yes. Because the head of the object, incident ray, would hit the mirror. So incident ray from the head is hitting the mirror, यानी इमेज बननी चाहिए. और अगर इमेज को ट्रेस करेंगे कुछ इस तरह से, this is the image of the object, this is the head, this is the feet. That means formation of image has no link with the size of mirror. कहने का मतलब a complete image is formed whatever be the size of mirror. Whatever. Even a very very tiny mirror will form a complete image. Reason? Image बनने के लिए you require at least 2 reflected rays, and you can imagine what may be the size of mirror to accommodate 2 reflected rays. So therefore we generalize it कि mirror के size कुछ भी हो, image complete बनेंगे. Then let's try to see what is the effect of size of mirror. मान लेते for this size 1000 rays are coming and hitting the mirror. ध्यान से देखना, ऑब्जेक्ट से इनफाइनाइट नंबर ऑफ रेज आर इमैनेटिंग, बट आई एम अज्यूमिंग 1000 रेज आर पार्टिसिपेटिंग फॉर द इमेज. यानी टॉप ऑफ द मिरर और बॉटम ऑफ द मिरर तक जितने भी रेज फॉल कर रहे, these are only participating for the image formation. And if you would backtrace, all this is going to reach the head. If I increase the size of the mirror additionally, then more number of rays would participate, but you know the rays are going to meet at the same point. तो location of image नहीं बदलेगी क्योंकि additional जो extra rays आ रहे वो भी जाके मिलेंगे तो यहीं पर. But this time more number of rays are participating for the image formation. यानी the direct effect is on the brightness of the image. तो कहने का मतलब if size of mirror is increased, the brightness of image increases. So this is a very nice concept what you got. Let's see now, ये है formation of image whatever be the size of the mirror. But image formation and image seeing are two different things. यानी image बनना ये अलग बात है और image दिखाई देना ये अलग बात है. So the question comes, when is an image seen? Let's see. An image is seen when the reflected ray reach the eye. I'll give you a very simple example. मान लेते आई हैव अ मिरर और यहां पर है एक ऑब्जेक्ट. there are thousands and thousands of rays participating to form the image. But अगर हम extreme rays को देखेंगे, this is the situation. यानी बाकी जितने भी rays आ रहे हैं, they will be between this point and this point. So, at a given distance, this particular area is also called as the field. कहने का मतलब, imagine you are walking along this line with the eye pointed this direction, and you have started to walk from here. Moment you enter this point, the reflected ray will enter your eye, यानी इमेज दिखाई देगी. इसके बाद seeing in this direction, when you move from this point to this point, you will continuously see the image, क्योंकि there are thousands of rays in this region and all will reach the eye. So this is the field. मतलब यहां से यहां तक आप जाओगे, इस एरिया पे आपको इमेज दिखाई देगी. Naturally, if you start walking here, then this is the field, because you enter, the reflected ray enters your eye right from here till this point. So that is the meaning of seeing an image. यानी image तभी बनेंगी, image will be formed when incident ray hits the mirror. That concept we have seen. और अब image तभी दिखाई देगी, image will be seen when reflected ray reaches the eye of the observer. Let me strengthen this concept with one more example. Imagine you are standing in front of a mirror. So, ये है mirror, and you are standing here, and this is the feet, this is the eye, and this is the head. Figure not to scale, but this is the head to eye, this is the eye to feet distance, और ये mirror है. पहला question, head is not directly in front of the mirror, तो क्या head की image बनेगी? The answer is obviously yes, क्योंकि there are many other points in the mirror where the incident ray from the head will hit. यानी complete image of the person would be formed. But अब सवाल है to see the image. Look, there are infinite number of rays from the head which is participating to form the image, but only one ray is responsible for seeing the image. So this is the ray due to which the image of head will be seen. Similarly, there are infinite number of rays coming from foot, but only this ray is participating so that the foot would be seen. बाकी से भी rays निकल रहे, or they are participating in image formation, but only this ray is able to reach the eye. So this is participating to get the image seen. If I assume foot as a point, and if I make a small hole at this point, first question, is the image of feet formed? The answer is yes, क्योंकि सिर्फ ये point नहीं है, बाकी point भी image बनने के लिए responsible है. But क्या foot दिखाई देगी? Answer is no, because this is the point which is helping for the ray to reach the eye. Up, let me use simple geometry. This is only the minimum size of mirror I require. If this distance is x, this would also be x, क्योंकि ये एक isosceles triangle बन रहा है, angle of incidence, angle of reflection. If this distance is y, this distance is also y. Up, if I project it further, ये length x और ये length y, यानी total length is x plus y. This is the minimum size of the mirror. यानी I could see, to see one's image, you could see size of mirror should be at least greater than equal to 1/2 the size of person. So this is the condition, yani these are the examples that helps you to decide how to see the image. One thing may be very interesting here. This calculation is independent of the separation between the man and the mirror. आप देख सकते हो ये दूरी मायने नहीं रखता है. That will always be equal and equal. This would always be equal and equal. But yes, one condition is required. You could see this is the ground where the feet is there. So the lower edge of the mirror, अगर इसको size of the mirror मानेंगे, should be at a distance y. And what is y? The eye to feet distance is 2y, almost the height of the man, and half of that is y. Let's see one more question for visibility of image. So let me continue with one more example. Imagine ये है एक plane mirror and there is a wall and a person is situated at the midpoint of the mirror and wall. I said midpoint, and this time let me get interested only in the eye of the observer. This person is observing the wall via mirror. So the eye of the person is positioned here. Let's say I have to see that ray which reaches the eye of the person. Similarly, the ray from the bottom of the wall is this. So this is the ray जिसके मदद से bottom of the wall दिखाई देगी, and this is the ray जिसके मदद से top of the wall दिखाई देगी. Rest is calculation. Be prepared for simple geometry. अगर ये distance x है, ये भी x है, और ये दूरी y है, ये दूरी भी y, क्योंकि ये एक isosceles triangle बन रहा है. Now here, this is y, this is y, and this is x, this is x. Likewise, this is x, and this is y. आगे देखते, अगर ये डिस्टेंस y है तो ये डिस्टेंस 2y होगी, कारण ये एक ट्रायंगल बन रहा है और ये पॉइंट मिड में है. सिमिलरली ये डिस्टेंस x है तो ये बन जाएगा 2x. अब आप क्लियरली देख सकते हो मिनिमम लेंथ ऑफ द मिरर इज x plus y and the length of the wall is 3x plus 3y. So if the man is at the midpoint, हम देख सकते the minimum size of the mirror required is 1/3 of the size of the wall. So I hope now you are comfortable for the concept regarding seeing the image. Now let's have another point, and that is the deviation. Let's see what's the meaning of that. पहले define करते हैं. It is the angle between इंसिडेंट एंड रिफ्लेक्टेड रे, तो इसको कहते डेविएशन, द एंगल बिटवीन इंसिडेंट एंड रिफ्लेक्टेड रे। जैसे आई हैव अ मिरर, और ये एंगल ऑफ इंसिडेंस आई, ऑब्वियसली रिफ्लेक्टेड एंगल इज ऑल्सो आई। अब हमें ये रे और ये रे, इनके बीच के एंगल देखनी है। बट इन ऑप्टिक्स बी केयरफुल, जब भी हम दो रेज के बीच के एंगल कहते, वी ऑलवेज मीन टू से द वेक्टोरियल फॉर्म, यानी अगर डायरेक्शन को नहीं देखे, ये लाइन और ये लाइन के बीच में एंगल 2i है, पर अगर डायरेक्शन को अकाउंट में लिया जाए तो ये इंसिडेंट रे वेक्टर है और ये रिफ्लेक्टेड रे वेक्टर है, और ये जो एंगल है 2i है। बट ऑन द बेसिस ऑफ वेक्टर, दिस इज नॉट द डेफिनेशन ऑफ एंगल बिटवीन टू वेक्टर। साफ पता चल रहा है, इफ आई ब्रिंग इट डाउन, दैट एंगल वुड बी पाई माइनस 2i, और ये वेक्टर ब्रॉट डाउन, दैट इज द एंगल बिटवीन द टू वेक्टर। यानी डेविएशन डेल्टा, इफ आई रिप्रेजेंट फॉर वन रिफ्लेक्शन, इज पाई माइनस ऑफ 2i, एंड दिस कैन बी जनरलाइज्ड। चाहे कोई भी मिरर हो, चाहे प्लेन मिरर हो या कर्व मिरर हो, the laws of reflection is defined at a point, so this deviation is valid for any reflection, but this is for one reflection. But many times you get a complicated geometry. जैसे मान लेते, if I show a very hypothetical situation, suppose a ray comes here, goes here, not hypothetical, but let's say complicated situation. This is one situation, and mirror यहां रखा है, और मान लेते ray is deviated here. As per the logic, we have to find the angle between this ray and this ray, that is the net deviation. यानी angle between this and angle between this. So I have to extrapolate. extrapolate it and use lot of geometry. But there is one very simple technique. You can individually find the deviation. ये deviation delta 1, ये deviation delta 2 और ये deviation को delta 3 कहते हैं. और each deviation will be related by this formula. और आप देख सकते हो ये deviation के लिए that's anti-clockwise, ये deviation clockwise और ये deviation भी clockwise है. तो अगर दो clockwise को मैं ऐड करूं, delta net will be delta 2 plus delta 3 minus of delta 1. I took positive sign as clockwise and negative sign as anti-clockwise. So this is how we find the net deviation. Let me show with an example based on this. Imagine I have two plane mirrors, but let's say the mirrors are inclined in this way. और ये है angle between the mirror. Let's say I randomly throw a ray in this way, and this can be traced very easily by following the simple common sense. And let's try to find the net deviation. I'll first draw the normal here. So this is the normal. और ये angle of incidence और ये angle of reflection, and this would also be equals to I. Now based on I and theta, I have to find this angle of incidence, जो कि we can do by number of ways, but आप देख सकते हो ये normal है, ये I है, तो ये angle होगा pi by 2 minus of I. And let me even find this angle. This plus this plus this is 180. तो ये जो बनेगा that will be pi by 2 plus I minus theta. और ये लाइन नॉर्मल है, ये मिरर, इनके बीच में एंगल पाई बाई 2, यानी दिस एंगल विल बी थीटा माइनस ऑफ आई. तो दिस इज द एंगल ऑफ इंसिडेंस हियर. एंगल ऑफ रिफ्लेक्शन वुड आल्सो बी थीटा माइनस आई. यू हैव टू बी एवर रेडी टू यूज ज्योमेट्री. अब देखते, ये रिफ्लेक्शन इज गिविंग एंटी क्लॉकवाइज डेविएशन और ये भी एंटी क्लॉकवाइज डेविएशन है, तो दोनों डेविएशन एड अप होंगे. तो डेल्टा नेट पहले के लिए पाई माइनस 2i और अगले के लिए पाई माइनस 2 थीटा माइनस ऑफ आई. एंड इफ यू ऐड दैट्स कमिंग आउट टू बी 2 पाई माइनस 2 थीटा. That result is coming independent of angle of incidence. That's the reason why the question did not give angle of incidence. But you could see one interesting thing, that if theta equals to pi by 2, तो डेल्टा नेट का जो वैल्यू है वो पाई आ रहा है. यानी मेरे पास दो प्लेन मिरर है एट एन एंगल ऑफ 90 डिग्री. यू थ्रो एट एनी एंगल ऑफ इंसिडेंस, द इंसिडेंट रे एंड द इमर्जेंट रे आर एंटी पैरेलल. ये रे और ये रे के बीच में एंगल है पाई. In fact, this result can also be extended for three mutually perpendicular mirror, but that requires a bit vectorial way of approach, क्योंकि 3 dimension में to draw the geometry is quite complicated. So this is how we find the deviation. So let's continue with some more examples. और इस बार हम देखेंगे velocity of image. Let's see how to deal or how to tackle the numericals related to velocity of image. पहले simplified way में concept develop करते हैं. अगर एक plane mirror मेरे पास है and an object is here, we can see इस object की image यहां पर बनेगी. Now, if I move the object in this direction, it is logically clear the image will move in this direction. और जो डिस्टेंस ऑब्जेक्ट मूव करेगा वही डिस्टेंस इमेज भी मूव करेगा, क्योंकि बाद में जाके भी ऑब्जेक्ट डिस्टेंस और इमेज डिस्टेंस हैज टू बी सेम. यानी स्पीड ऑफ द ऑब्जेक्ट एंड स्पीड ऑफ द इमेज विल बी सेम. फर्क है डायरेक्शन. डायरेक्शन वुड बी अपोजिट. सो वी कुड सी इफ वेलोसिटी इज along the normal, अगर वेलोसिटी नॉर्मल के along है, या इसको कहा जा सकता है perpendicular to the mirror, all is same, then velocity of image is minus of velocity of object. Negative sign बता रहा है, the direction is opposite or magnitude wise it is equal. One more, let's see. ये मिरर है और ऑब्जेक्ट यहां पर है, और इस सिचुएशन में इमेज यहां होगी. इमेजिन ऑब्जेक्ट इज मूविंग अप. इट इज वेरी क्लियर व्हेन द ऑब्जेक्ट रीचेस हियर, उसी समय पे एट द सेम टाइम इमेज भी इस पॉइंट पे पहुंचेगी, यानी इमेज वेलोसिटी वुड बी सेम. दिस टाइम सेम इन मैग्नीट्यूड as well as direction. So let's make the concept now. If velocity is perpendicular to normal, then we get velocity of image vector is equal to velocity of object vector. Same in terms of magnitude as well as direction. Application देखते हैं. Example, let's see. Imagine a plane mirror is here at an angle theta, and this is the plane mirror. Suppose object is here, an object is moving with a speed u. और क्वेश्चन है, find velocity of image with respect to object and its magnitude. First point, when the object is here, where is the image? रिमेंबर, जब भी हम कहते हैं ऑब्जेक्ट डिस्टेंस इक्वल्स टू इमेज डिस्टेंस, वो जो डिस्टेंस है वो परपेंडिकुलर डिस्टेंस है. सो हियर इज द सिचुएशन. दैट मीन्स इफ आई ड्रॉ द परपेंडिकुलर डिस्टेंस, यू कुड सी ऑब्जेक्ट इज हियर, इमेज इज हियर. एंड व्हाट इज द सेकंड स्टेप? इफ यू नो वेलोसिटी अलोंग द नॉर्मल एंड परपेंडिकुलर टू द नॉर्मल, यू कुड इजीली फाइंड द वेलोसिटी ऑफ इमेज. तो यहां पर भी इस वेलोसिटी को हमें रिजॉल्व करनी है along the normal and perpendicular to the normal. Let's see. If I extend it, ये theta, तो ये theta, this is theta, यानी this angle will be 90 minus theta or pi by 2 minus theta. Now what I'll do, this is the mirror. Let me resolve the velocity along the normal, perpendicular to the normal. Along the normal, velocity is u sin theta, u cos pi by 2 minus theta. और perpendicular to the normal, u sin pi by 2 minus theta, यानी u cos theta. कहने का मतलब इस वेलोसिटी को एक ये डायरेक्शन और एक ये डायरेक्शन में रिजॉल्व किया है. अब देखते हैं. Image at this instant is at this point. This velocity will be reversed. और ये जो velocity would be same in magnitude and direction. There it is. ये है object velocity और ये है image velocity. और question है to find the relative velocity. So if I subtract, this part will get cancelled. So ये जो required चीज है, that's 2u multiplied by sin theta. So this is how we deal the situation of velocity of image when velocity of object is given. But let me continue the same numerical, but this time let me make it a more mathematical. मान लेते हैं given a mirror is in YZ plane and mirror is not at rest. Suppose mirror का जो velocity है, velocity of mirror is 5i cap minus 2j cap. यानी mirror itself is moving. और velocity of object given है, say 2i cap minus 3j cap plus k cap. And based on this, we have to find velocity of image. Let's see. The basic bottom line is the same thing. But ये चीज derive किया गया था when mirror was at rest. So if the mirror is moving, this concept cannot be applied. But as a physics student, you can bring anything to at rest, provided हम relative motion के concept use करेंगे. तो पहले चीज आइडेंटिफाई कीजिए, मिरर अगर YZ प्लेन में, तो इसके जो नॉर्मल है, obviously that will be along the x-axis. That's a normal. अब velocity of object with respect to mirror ये निकालते हैं. If I do this, mathematically mirror is at rest. So let's see, object with respect to mirror minus 3i cap minus of j cap, this minus this, plus of k cap. This velocity, let me split it according to my need. Why did I split? Because normal is along x-axis. यानी ये velocity is along the normal और ये velocity is perpendicular to the normal. और इस समय जब object with respect to mirror कहेंगे, mirror is at rest. तो इसके corresponding velocity of image with respect to mirror, ये देखते हैं. X component will get flipped क्योंकि normal के along जो है that will be minus same magnitude, तो ये बन जाएगा plus 3i cap और ये component perpendicular to the normal है, यानी इसके magnitude और direction would be same, तो ये बन जाएगा plus minus 1 j cap plus 1 k cap as it is. But ये है velocity of image with respect to mirror. अब इसको मैं velocity of image निकालूं, वो बन जाएगा image with respect to mirror plus velocity of mirror. All I need to do is 3i minus j plus k. ये है velocity of image with respect to mirror plus velocity of mirror. So whatever comes is the velocity of image. So this concept is used in order to find velocity of image for any given sort of situation. Now, let me discuss how to indicate reflection vectorially. Let's see. You have seen if any reflection of mirror is there, or if any reflection of light goes through the mirror, the model is exactly an elastic collision. So somebody gives me a mirror. This is the normal vector, and I know this is incident ray this is reflected ray. और quite easily हम देख सकते, we can compare with the collision of a ball with the wall, provided collision is elastic. तो उसी situation में this angle and this angle would be same. Now how do we do any question of collision when it is elastic? Imagine I have this velocity 5 meter per second at an angle 60 degree. We resolve the velocity 5 cos 60, 5 sin 60. And the reflected velocity, this component remains as it is. And this component would get flipped. So the technique is same. And the resultant of this and this will be the reflected velocity. So what should I do? First of all, I have to split incident ray into two parts. This is I1, this is I2. And I can write I vector is I1 vector plus I2 vector. Now what is I1? I1 is component of incident ray along the normal. तो वेक्टर के हेल्प से I1 vector is I vector dot n cap multiplied by n cap, where n cap is a unit vector along the normal. तो ये बता रहा है component of incident ray along the normal. What is I2? Component of incident ray perpendicular to the normal. Now you could write I2 vector is I vector minus of I1 vector. क्योंकि I vector has been split up into two components, तो एक हिस्सा अगर I1 है, दूसरा हिस्सा can be easily found out. Now, if I have to define reflected ray vectorially, आप देख सकते हो I1 vector would be flipped, तो वो बन जाएगा minus I1 vector, putting the whole package here, and I2 vector will remain as it is. So this is how we represent reflections vectorially. Now every numerical as of now we have done is we have shown when the object is real. Let me try to show the situation when object is virtual. Let's see. मान लेते मेरे पास ये एक प्लेन मिरर है और by any means I am getting this ray. अब हम आसानी से रिकॉग्नाइज कर सकते this is the situation of virtual object, क्योंकि ये इंसिडेंट रे है, there is no chance of meeting this side, और अगर इसको एक्सट्रापोलेट करेंगे it will appear to meet here. But चाहे रियल ऑब्जेक्ट हो, वर्चुअल ऑब्जेक्ट हो, remember mirror does not know what an object is. Mirror only knows if a light comes, it has to reflect. I have seen many times you think whether the laws of reflection are valid or not. But the idea is the word object and image is named by us. For the mirror, rule is very simple. अगर कोई light आ रही है, it has to reflect according to the laws of reflection. So let me do that. Here it will get reflected, and for this ray, it will get reflected in this way. This is a point where the reflected rays are truly meeting. So obviously, this is the case of real image. That means a plane mirror can form a real image, but that's when the object is virtual. So we can write here, a plane mirror forms real image when object is virtual. We can also take it analytically. If we had extrapolated this incident ray, it would appear to meet at this point. Yani this is the case of virtual object. Or simple geometry is indicating this distance is equal to this distance. कहने का मतलब that rule is still valid. Object distance और image distance बराबर है. फर्क यही है, when the object is virtual, image is real. Let me show a numerical. So let me show an example. मान लेते mirror is in this way and this is at an angle 60 degree. Suppose a ray which in absence of mirror would converge here is hitting a mirror और ये दूरी मान लेते 10 सेंटीमीटर. Try to interpret ये इंसिडेंट रे मिरर के एब्सेंस में द रे वुड मीट हियर और हमें निकालना है पोजीशन ऑफ इमेज. इन अदर वर्ड द पॉइंट वेयर द रेज वुड मीट. वन वे, इवन विदाउट द नॉलेज ऑफ ऑब्जेक्ट एंड इमेज, ज्योमेट्री की मदद से अगर हम ट्रेस आउट करेंगे विल गेट इट. बट दिस टाइम दैट बिकम्स अ बिट कॉम्प्लिकेटेड. सो फर्स्ट ऑफ ऑल लेट्स calculate the object distance which is not equal to 10. क्योंकि ये object तो है, but object distance would be this. Every distances are measured perpendicularly when it comes for object distance या image distance. And you could see this length now will be 10 sine 60 which is 5 root 3. Object distance 5 root 3 है. Image distance would be here and this is the location of image. So you could easily find the location of image. Ray tracing आप verification के लिए कर सकते हैं. This is the point where the rays are meeting. So catch this idea. अगर यही चीज if you had geometrical devices you could calculate the angle and you could trace it, but that is not in our hand. Yani, we calculate it algebraically or logically, and finally, just for a validity's sake, to get some intuitive feel, we trace the ray diagram. So the level of optics that we deal is we always take it logically, like how we calculated the object distance, then we found the image distance. But if you have geometrical devices, without this knowledge, simply by verifying the properties of reflection, you could calculate the position of image. So students, the first exposure of optics, what we have discussed is what's a plane mirror, what are the laws of reflection, and I think this has now implanted a basic concept how to deal with optics. In the next lecture, we'll promote ourselves to spherical mirror. Till then, practice and absorb the concept properly. Thank you.